I'm Karthik, Product Marketing Manager. Been with NGINX for about 6 months. And I'm here to talk about the total cost of ownership and ROI of NGINX Application Platform. This is a brief overview of the agenda. Talk about what are the various elements of the TCO are. Point out some case studies that demonstrate these value propositions, sources of value that we've identified. And this is going to be interesting. I've actually developed an ROI tool. We'll go through that quickly, and then finally Q&A. So, application delivery, application modernization is the core of digital transformation. I think most of you here have already embarked on some sort of transformation activities. But what's really a TCO of achieving this, especially when you have NGINX? So these are the 5 elements that I have identified. Complexity, reducing complexity, enabling you to be more agile, multi-cloud versatility, and that helps you with reducing costs, achieving consistent results and performance, increasing revenue with APIs, and finally reducing costs. So let's go through each one of these, right? So by complexity, what I mean is, you probably have variety of different kinds of applications, monolithic applications, hybrid apps, meaning you're just exposing some of these services for these apps via APIs, and also dipping your toes in microservices. That's what I mean by complexity, as in you have a variety of different kinds of applications at different stages of maturity. Some are on-premise, some are in multi-cloud environments. How do you manage all this, especially when it comes to traffic routing? Infrastructure is also, there are infrastructure shifts that are happening. So gone are the days when you have a shared services organization that's providing an infrastructure based from corporate IT is providing the infrastructure, and that has to be portioned off to development, QA, production. Nowadays, I think probably, as you guys know, DevOps teams themselves deploy infrastructure. They do not want to share the infrastructure across multiple applications. In fact, many of our customers have their own load balancers and their own reverse proxies for their applications. But going beyond that, in a SaaS company, a big SaaS customer of ours just last month, they are having a load balancer per customer. So it's really this sort of decentralized way of configuring your infrastructure, in this case load balancers, providing you with a lot more flexibility so you can easily make changes, configuration changes. If you want to increase scale, if you want to deploy a new app, all of that is much more agile and nimble if you have basically almost like an infrastructure per application or per customer. You've seen this. Sydney had spoken about this briefly at yesterday's keynote. So let me go into more detail about this. This is a well-known customer, well-known brand in household name Genealogical. They offer online genealogical services, right? And this is basically their setup, right? You have a CDN going into a WAF, L4 load balancer, L7 load balancer, API gateway, and back into an L4 load balancer that talks to a monolithic app reverse proxy, and they're also having some of their applications using microservices, Kubernetes ingress controller, and via the sidecar proxy. They have SGO framework for microservices, and via the sidecar proxy there. So they have 13 solutions. They don't have all of these, but these are the various flavors. They could have, a customer could have Akamai, a CDN. They have Akamai, and they have Imperva for WAF. But basically, they had 13 different solutions, including NGINX. And the data plane basically is the dark gray, and the control plane is light gray, right? So you automatically have, first of all, just this tool sprawl. Your engineers, DevOps folks, as well as INO folks there's a steep learning curve associated with each of these tools. It's just very complex, to be able to, again, make changes, even increase scale, whatever the case may be, right? So they've been able to, from 13 they've just moved to 3 solutions, right? Many of our customers actually could use us as a CDN as well. They are going with Akamai. But everything else has been collapsed into, via a reverse proxy, load balancer, API gateway. They're using NGINX Unit as an app server for their monolithic apps, and NGINX is the Ingress controller, basically. NGINX Plus is Ingress controller for their microservices. This is a very powerful story that has resonated very well with our customers, to be able to collapse, again, multiple different solutions and just use NGINX Plus. Is that the case with all of you guys? Like, you have, if not 13 different solutions, some flavor of, okay. Yeah, as I mentioned, that's exactly what we've heard. So, and that cuts cost 80%. Now I'll actually talk about how, much more in detail about the cost angle. Agility, these are some of the buzzwords that I've heard: being able to do A/B testing, blue-green deployments, rapid release cycle. Feature velocity is a big deal when it comes to digital transformation. So what I mean by that is, you have Amazon, after they moved to AWS, which is a long time back, they've been able to, this is crazy stats here, deploying code every 11, 12 seconds, right? But they are really the one extreme. You have Nordstrom, new release from mobile app went from twice a year to monthly. Fidelity, which has been around since 1948, we all know about Fidelity, release time reduced from days to just a few hours, right? All of this is possible with automation, sophisticated CI/CD pipelines. I think at Fidelity, or at Nordstrom, they were actually deploying each and every app manually, configuring the infrastructure. And there's this, I used to be a software developer as well in the early 2000s, and there's a lot of processes. There's a way to roll it into a build. There are build tools, release management, all of that. I think you probably are familiar with, but with DevOps and automation, they've been able to do this. Now, from our customers, and load balancer has been key to achieving this rapid feature velocity. What we've heard from our customers is these are some of the challenges with what I call legacy load balancers, right? Hardware-based load balancers. Very cumbersome to implement config changes for the load balancer or for the application. So one of our customers, a big bank in Australia, they have a parallel set of F5 infrastructure just to test. And the testing when they make a config change, it involves actually making the config change, implementing the config change, then actually testing it. And all of that takes about a whole full week. They have to submit IT tickets. So it's not just making the change. Making the change itself can be done quickly, but it's the waiting time involved in submitting IT tickets. And it's also centralized across all of their applications. So that's why they're very, very careful about making any changes. Some of them, because of all of these difficulties involved in actually making the changes, some of them completely forego all of these. So they just deploy the app in production without doing sort of a blue-green deployment, without actually having a testing framework at all. So it's not exactly great, but they're avoiding all the cumbersome issues involved with making changes, but it leads to issues in production. So there are defects in production once they roll it out. There's downtime, poor performance, and because they are actually making the change right in production, that feature velocity going back to just twice a year or even once a year, that also is much reduced. So this customer with NGINX, on a per app basis, they're able to deploy their load balancer. They have about 20 different applications, and each and every application has a specific load balancer. Making change, they don't have to. These are DevOps folks. They don't have to submit a ticket to IT. Very fast to make changes to NGINX, to actually move a workload on a VM, to deploy an application, whatever the case may be. And they're able to do that. So now they're not able to, there's no risk associated with deploying this in production, because they're able to actually do all these tests, what I call risk-free deployment in production environment, right? There are no performance issues, no downtime. Sure, by that, when I say no downtime because of making a config change. There could be other kinds of downtime, network downtime issues, but there's no downtime associated with this, right? Question so far, is this something that you guys have in your environment? I don't know if you've moved to NGINX or if you're using a hardware load balancer. Are these some of the challenges that you have? Okay, that's good. Let's go through a case study, right? So Montana Interactive is a e-government solutions provider, service provider. So they provide, they support basically hundreds of e-government solutions in partnership with city, state, and county entities in Montana. So this is an interesting case study. This person, James Riddle, I guess, they manage, first of all, up to 200 e-government applications, 650,000 users per month. They were using Pound as a reverse proxy, software-based, running on a VM, and every time they need to increase scale, deploy a new app, move workloads on the VM, and they had deployed 2 VMs, they had to increase the number of threads. And literally, they had to restart at 2 a.m. every night or every morning. And his goal was that, actually. My sole goal is not cost, it really is, I don't want to wake up at 2 a.m. to restart my VMs. That was his goal, right? And they started using NGINX Plus as a reverse proxy. We have capabilities on the NGINX Plus side, on-the-fly reconfiguration, so being able to dynamically make change without restarting NGINX. And we have active health checks, pinging all your upstream servers, and if anything is down, make sure that it's load balanced with the remaining servers. So they were able to, first of all, not wake up at 2 a.m. and restart because it's done automatically now, and being able to make config changes to upstream server groups, without disruption to users, right? Pretty powerfully. This is just a very illustrative use case that I picked out just for this, to illustrate this point. Moving on, multi-cloud versatility. I think, how many of you have, multiple clouds here? Okay, only 1, 2, okay. Others, you have your own cloud, or you're using only one single cloud, public, AWS or Azure? Because what I hear is, most of the organizations, about 85% according to a survey, for disaster recovery purposes, to make sure that, also, Google, for example, GCP is apparently geared for handling machine learning workloads. So people are also very selective about the kinds of workloads they have and choose accordingly the public cloud environment that they want to adapt. Mainly, again, to prevent a single point of failure, to have a good, adequate disaster recovery scenario, they use multiple clouds and avoiding vendor lock-in, right? I don't know, I think some of you may be familiar, but we can be deployed literally anywhere, bare metal, public cloud, private cloud, VMs, containers, because it can be containerized both NGINX Plus and NGINX Controller, it really is very versatile. The benefit of this is, sure, benefits of multi-cloud, I was talking about, avoiding vendor lock-in. From a load balancing standpoint, it's getting consistent performance and reliable performance in any environment, right? So if you're using your public cloud just as a test environment and moving back to on-premise, if you're using AWS's load balancer, that could give you a different set of results. And when you move it on-premise, you're probably going to, and if you're using NGINX Plus, it could give you a different set of results, right? So to achieve that consistency, ensure there's no nasty surprises, either with cost. I think probably I would say the cost of any cloud there is significant actual dollar cost involved. But avoiding nasty surprises, whether it comes to performance, cost, whatever the case may be, and being able to achieve consistent results in any environment. That's what our customers have found, even though, of course, there are load balancers in any of these public cloud environments as well. So case study here that I'd like to showcase is Reliam. They are a managed service provider for managing your public cloud environments, helping organizations migrate to and managing, optimizing workloads in the public cloud environment. They basically, actually, interesting case study. They are they manage top high-profile internet applications and events for some of the top global brands like Nissan, Miss Universe, Oscars, Grammys. So this is what they need to support. 1 million page views, 60,000 simultaneous visitors, and because they are a public cloud provider and they provide management services for any cloud, they needed again a consistent application delivery mechanism. Basically remove the application delivery from the actual business logic of the application itself, right? Ensure that there's no variation in performance along those lines. And they used, during Nissan's 2015 Super Bowl ad campaign, for proxying users to YouTube and Twitter. And they were able to achieve consistent, reliable results across all platforms because they supported all platforms. Are any of you using third-party cloud service providers to manage your clouds? Okay, that's great that you guys are all doing it yourself. I want to now shift gears to increasing revenue. So there were a couple of sessions today or yesterday and in our keynote, how NGINX is an API gateway. 40% of our customers use us as an API gateway. Some of the features are being able to route clients to the correct API endpoint, caching commonly used API responses to improve performance, API authentication using JWT, and finally, last but not least, rate limiting. If you're having a DDoS attack, ensure limit calls to your backend APIs. But even more than that, DDoS is a great use case for rate limiting. But this is a slide that I want. You can actually increase revenues by what I call APIizing your all your services, right? So you first are unlocking data. Different disparate teams are not talking to each other right now. APIs facilitate a common way of communication and unlocking data between, let's say, marketing and supply chain, marketing and finance. First and foremost internally, and you get great value out of that, internal applications. And that's what Adobe has done. They have 10,000 developers. And just being able to collaborate faster, quicker amongst all the applications, amongst the developers. They've been using NGINX, breaking down silos. But going beyond that, Capital One has a dev portal, uses NGINX, and they have a variety of apps to open a bank account, to showcase rewards for for their customers. Also for their ecosystem partners of developers, from simple applications like opening a bank account to being able to generate rewards based on what the usage patterns of the end user, right? So it's really a way to monetize the data that you have. Adobe as well, actually, they've through APIs being able to provide integrations, add-ons to all their applications. There are 10,000 developers use it internally, but also they've opened it up to external users who want to develop integrations and add-ons for Adobe applications, right? So that's where I see potentially by using NGINX as an API gateway, you can actually have the potential to even increase revenues, offer new digital streams of revenue and services. Finally, cutting costs. So this is a survey we did with O'Reilly Media in Jan 2018, about 250 customers. 50% really don't know how much they spend on their hardware load balancer, and 70% they just have a lot of hardware load balancers. Basically, they have a lot of them. They don't know how to account. They don't even know how much are accounted for. Basic sort of asset tracking. And then once you have the load balancer, you're not even using all of the features that you bought it for. So 90%. Well, first of all, these load balancers have a lot of very advanced features, except that not many people use it, and not many people even know about it, right? So you're paying money and not using it because you don't need it. At the same time, you also don't know actually how much you actually have. Is this something that, again, you have in your, okay. See some heads nodding. So I'm gonna make a very explosive slide here. This is how much you can save. So now it's now time for me to switch to my ROI tool. So what that was an illustrative, oh, sorry. Okay, ooh, this is interesting. So the pie chart that I had was an illustrative example of the savings you can achieve. Let's go through the spreadsheet. So what I have here is the first tab here, just licensing and support costs, is going to be rolled out internally to our sales folks. Just, comparing NGINX against a status quo, typically a legacy hardware load balancer, right? So I have some of these prices here. First, for argument's sake, just as an illustrative sample, I've taken prices from my F5 system. And here, what we're comparing is if you have a hardware load balancer, 80 gig speed, and you have 3 HA load balancer pairs, so that's about 6. Even include the discount. And these are the prices, right, for the hardware load balancer, and this is the price for us. We are a subscription-based service, so I think I count it as support cost of each load balancer. You also, because it's a software, you also need to account for the server cost. And then you also have to take into account the management. So I guess F5 system, they have a management called BigIQ. And what's the cost of that? What's the support cost of that? In our case, we have controller. So if you take into account all of that, this is the saving for this configuration. For actually 6 high-end hardware-based load balancers, 80 gig, compared to, on the NGINX side, 10 10 software-based load balancers, same high-end, right? So CapEx, initial investment close to 600K, and annual OpEx is about, 71K. But wait, there's more. This is just pure sort of licensing cost comparison. Things I had mentioned earlier about ease of making configuration changes. So let's say you have 10 applications, you need to make 5 changes per year per application. And these are the steps needed to make a change. So to implement each configuration, to test it, and then to actually roll it out. So broken the 3 steps, actually making the change, testing it out, and actually rolling it out in production, it comes to about 40 hours. These are roughly a week. This is data from our customers. Because again, it's not just actual time involved in making the change, it's some IT tickets and waiting for your IT personnel to resolve those tickets. And so it comes down to about 40 hours per week. So if you multiply, basically, you need to, you have 50 different, you need to make changes 50 different times throughout the year, 10 applications 5 times a year, and 50 times 40 is about 2,000 hours, right? And I've assumed 100K for an I&O engineer. This is data that I got from BLS, Bureau of Labor Statistics. We can probably look at Glassdoor, there are other sources, and your values may be different. But our line of the sand, our basically point of view is that we can actually save 95% of this time, right? Of this time. So that comes to about literally the entire cost of of that person. That doesn't mean that person has to go. It's just better use of that person's time rather than just making changes to the iRules or whatever the case may be, right? So that's what we call operational agility. Then you have risky deployments in production. So I'm actually I'm gonna not even do any testing. I'm just gonna make changes and deploy it in production. What is the cost of that? So let's say you have 24 deployments per year. You have about defects. So because you're actually doing it in production, there are about 20 defects, and 2 hours your engineer needs to spend fixing the defect. So that comes to 960 hours. You have about 150K you need to pay this engineer. Half this person's time is actually spent on fixing defects, right? And again, the numbers can change. You can debate me on the numbers. This is just directionally what the savings how much savings you can get, right? That's what I want to point out. But this is an interesting data point. Like Gartner estimates about $5,600 per minute of network downtime, right? That's what folks experience, especially when they when they make any changes to production directly. And that comes to about 168K. So your total cost or savings that you can achieve with using NGINX, because you are able to have, you're able to, you don't have to deploy directly in production. You have this blue-green setup. You're eliminating downtime, at least not caused by, load balancing issues. So that comes to about 243K, right? Finally, you have also these things. I don't even have sort of sample values, but I want to account for folks, coming to your website and what we call bounce rate, site abandonment rate, not actually checking out your website and going to a competitor site because you're too slow. You don't have to be down. You're just too slow. And I found a stat actually, 7%, the cost of sort of, decline in web traffic, even for a 1-second delay, is about 7% of the total number of visitors. 7% decline. 7% of, if let's say 100 folks come to your website, if there's 1-second delay, you get only 93. That's what I'm trying to say. And finally, again, another point of discussion, with increased feature velocity, if you assume digital revenues constitute 10% of your entire revenue, and you can actually increase with higher feature velocity by 2 more percent, what is the impact of that, right? So I have cost of performance and higher revenue with increased deployment velocity, right? So I think the point here is to really point out to your senior management that we are definitely, in the thick of operational aspects of rolling out a release, enabling, making sure that all your releases go smoothly. But going above and beyond that, we could actually contribute to top line revenue as well by having a smooth, software-based load balancer reverse proxy system. So that's what translates to some of the savings here, right? You have the breakup of cost savings, CapEx avoidance, 32%. This is sort of the pie chart that points out all the things we talked about. This is the benefit versus total cost of NGINX solution. So I'll pause here. Does this sound about right for the environments that you have? Anything you want to challenge me on? Anything that I've missed out? Assumptions that are wrong?
Did you include the cost of actually putting that thing in a data center, the physical one?
I did not.
Like power and...
Yeah, I did not actually. That's a great point. Yeah.
Yeah, it's quite a bit of money.
Right. Thank you for pointing that out. I'll add that. And I had a slide that talked about how we can be everything, right? API gateway, reverse proxy. This just talks about load balancer. So we're going to expand this tool to take into account how, if you're using an API gateway, what is the ROI of that, right? I should have started off with that. Thank you for pointing that out. So now, just have one more slide. Okay, so this is interesting. Ooh. Okay. So this is where basically I'm going to probably build this slide out. Let me just build it out. I think it's easier, right? Yeah. I think this is a maturity model of where our customers tend to be and how we can help at every stage of your journey, right? You have typically the adoption curves like that. You have legacy apps, monolithic apps, and the axes are, and the dimensions are application type, legacy and modern, and application architecture, 2-tier, 3-tier architectures, or single-tier architecture to distributed microservices. Monolithic apps, I think you're probably familiar. It doesn't have to be even an ERP system or CRM system. Just a typical Java app with a database. The main point there is you want to try to reduce the cost. It's difficult to just move all of your apps to modernize all of your apps in one go. Get that. But as you still have to maintain that, you at least can reduce costs, and north-south traffic performance is your main. That's the main thing that you should be concerned about. And you can either sweat out the hardware load balancer that you have, put NGINX behind a hardware load balancer, or actually rip it out, right? And point there is to at least reduce the cost as you're maintaining this monolithic app. Hybrid services, as you're thinking about opening up some of your applications with, exposing APIs for some of the applications. That's what we mean by hybrid services. You're dabbling in containers. You are containerizing basically some of these applications, and you're using Kubernetes or API. So let's say a mobile app. That's where an API gateway would be helpful. And finally, microservices, completely cloud-native application, born in the cloud, distributed, for newer apps, digital services. That's where NGINX as a service mesh can be helpful, right? And from our brand survey, a typical organization, I think within an organization, 60% of their applications are monolithic. That's what we heard from our customer base. 30% hybrid, 10% microservices, right? We, of course, expect the microservices the share of microservices to be higher as subsequent years. Is this, again, does this graph actually resonate with what you have in your setup? I was talking to, I guess I can name them, folks at Apple, and apparently they're all here. So that's interesting. Please, few organizations that are completely Microsoft heavy. So that's all I had, folks. Questions, comments? Yes.
One point I think is the split between, you mentioned like IT operations and
Right.
DevOps, right? You've got an immense legacy aggregation hardware and or appliances and or processes, and as an app team coming in place and putting platform or working along that line of digital services. I don't know what you've seen, but it seems like that's an immense ball of wax to me.
Yeah. I completely agree with you. I mean, I can talk about load balancer and how easy it is. That's great, but culture is very, very important. It should, I think this morning Margaret was talking about how maybe you have one or two departments write up microservices, start using containers, start adopting DevOps practices, and showcase the result to your seniors, to your superior management, to get their buy-in. Because like you said, I mean, if you don't have their buy-in, this culture, there is tools, when I say culture, I mean, and going back to culture, I mean, not strict silos. You should not have strict silos between your IT and DevOps team. There should be good degree of autonomy, and not driven by, a lengthy process document. Those are some of the things that are absolutely essential. Above and beyond, I mean, that should be the first step, to get buy-in from your organization, and have some level of understanding of what we mean by DevOps and what can actually operations folks participate in code reviews. Are they doing that now? And do they, they should probably be doing that if you're adopting DevOps, right? those are those are very critical.
The chart you had that had the scattering of logos.
Right.
Right, I think that's pretty common. But I think what's interesting is that is one product, but you may wrap that into an IT boundary, then you may wrap that into a global boundary, and you've got different ingress points.
Yeah.
All of that stuff, right?
Right, but at the same time, at least with DevOps, some of the guys are not exact. I guess they are bypassing IT, having their applications directly, exposed to external customers as well, right?
That doesn't take into account shadow IT as well. That's into that whole ecosystem, right?
Right.
Because then you find out that, hey, this development team here deployed X, Y, Z, and nobody in the organization even knew about
Right.
it except for that.
And that's bad too, I guess. Right. I mean, we need to get.
So, the feedback from the total cost of ownership is, I would say that some of those things are difficult to do, and to be honest, hardware cost is one thing, but the developer experience and being able to engage a developer
Sure.
in that manner is, I would argue, more beneficial, right? In order to get far
Right.
to the right, to increase that revenue line, you gotta get to that point where
Right.
you're engaged and it's not siloed, and I think the only way to get there is through technologies like this.
Right.
The software is the hardware,
Right. Well put. And to your point, I should probably include that as a cost, quote unquote, moving to software based. Yes.
So, with most of the presentations, the information is better available in blog posts and just reading. Is this stuff, this is actually the harder conversation with the technical side of a lot of these presentations that have in a lot of organizations. Is this all available in the spreadsheets? Is there a generic?
So, great question. So, first, we want to roll this out to our account managers this quarter, maybe 3-4 months, trial run at the model that I showed. Is that really real? Get some validation. By the way, I have spoken to some customers and it has resonated. It was not just generally developed when I was dreaming. But then, starting in the next 6 months, we would like to have something on our website for prospects to enter in. Not like 10,000 questions, just 5 questions, and then provide an ROI. And that is the goal, if that answers your question. Yeah, that is the goal, yes. Because I think it's a great buy-in tool to convince your own senior management, whatever, you guys are all probably key influencers, but not decision makers, to basically have collateral, have material for your decision maker, yes. Other questions? Okay, I think we are right about time, actually. So, thank you, folks. Thank you.